Hello everyone, welcome back to RP Learning. My name is Iman Andre. I am an instructor in mechanical department. Today, I'm going to teach you a lesson of lathe machine operations. In our session today, we are going to learn sharpening a single point cutting tool. Let's get started. At the end of this session, learner will be able to identify different types of lathe machine tools, and you will be also able to sharpen a single point cutting tool. There are three types of tools. For example, this is what we call a single point cutting tool with this type of higher speed steel. This is a solid cutting tool. The second one is a brazed cutting tool. If you look at this one, the cutting tool is only this tip placed on this support. For example, this one also is another brazed cutting tool or a brazed carbide cutting tool. This one, it's a boring tool. And this one can be a left hand. If you compare this one to this one, this is a right hand and this is a left hand. And both can be used for facing. And this is another one which can be used as a straight turning tool, but this one is a left hand tool, while this one it's a right hand tool because it works in this direction. The other type of tools is this one. This is an insert carbide cutting tool or an insert cutting tool. The cutting tool, it's an insert. The insert, it's a piece like this one. This is the tool. If you want to use it, you fix it on this support. The importance of this one, once one edge is broken, you can replace one edge by another edge. But this one cannot be resharpened, while the two other types can be resharpened using grinding wheel. All cutting tools are made in different material. For example, this one is made in higher speed steel, and those one, the tools here can be either a cemented carbide, it can also be a diamond, a ceramic, and even on this one, the insert can be made in a cemented carbide or a diamond or ceramics. Lathe tool bit should possess the following properties. They should be hard. If you compare the tool to the material you want to machine, a tool must be hard. They should be wear resistant. They should be capable of standing up to higher temperature developed during the cutting operation. They should be able to withstand shock during cutting operation. Now let's talk about what we call tool signature. We are going to use an example of a single point cutting tool made of higher speed steel. When we talk about tool signature, it is 7 elements of a single point cutting tool. Element number 1 is the back leg angle. If you look to the back leg angle, it's an angle located here. If you measure the angle, it's an angle just located above this top cutting tip. As you see, there is an angle here. And there is another back rack angle. It's an angle located here. If I take this protractor and I put it at 90 degrees and I put it here, there is an angle here. This is a side leg angle. There is another angle called end relief angle. This end relief angle, it's an angle located in the front of this single point. Just the angle located here. This is the end relief angle. There is another angle, a side relief angle. The side relief angle, it's just the angle located here. If you look here, just this angle here, it's the side relief angle. If you check, the angle located here is the side relief angle. There is another angle called end cutting edge. The end cutting edge angle, if I put this protractor here, the angle located here, just here, this is the side, the end cutting edge angle. There is another angle called side cutting edge angle. For this teaching material, this angle here it's equal to 0 because this tool maybe can be used if you want to obtain a right angle here. So that angle is supposed to be located here. For this teaching material, this angle is equal to 0, but that angle is supposed to be located here. And the last item of last element of tool signature is the nozzle radius. All tools must have a nozzle radius. So let us talk about the importance of those different angles. The side cutting edge, the angle located here, it does most of the cutting as the tool bit move along the workpiece. For example, if this is a cutting tool and this is a tool, as long as the tool moves along the workpiece, this angle, as the tool bit move along the cutting piece, the side cutting edge remove most of the material. This angle is designed to remove the material. The front cutting edge is the angle located just here in front. This one. This front cutting edge cut when the tool is advancing into the work. Suppose the workpiece is fixed in the chuck like this. The angle we are talking about is this one. As long as the cutting tool moves, this angle will help to remove metal. So the purpose of this nozzle, the nozzle is a critical part of the cutting edge because it produces the surface finish of the workpiece. So let's talk about the side leg angle. It's just the angle located here between this protractor and this edge. The purpose of this leg angle is to produce the side cutting edge that cut into the workpiece. There is another angle called the side relief angle. Is the side relief provide clearance that the side cutting edge without side relief, the side of the tool bit would hit the work. That angle is the angle located here. Without this angle, the tools will float to, will create a friction on the workpiece. While this angle is available, only the cutting edge will touch on the workpiece. The back leg is just the angle located on the top. This back leg, if you take this protractor, is just the angle located here. This one, this back leg, the front cutting edge cut when the tool is advanced into the work. The nozzle, as I said, the nozzle helps to produce a smooth surface. The back leg is the angle located here. Produce the front cutting edge that cut into the work. The front relief is just the angle located here in the front. When I take this protractor like this is the front relief. The front relief provides clearance for the front cutting edge. Without this front relief, the front of the tool bit would hit the workpiece and not allow the cutting edge to penetrate into the work. Remember, the cutter can move into the work. If there is no this angle, so it will not remove material. So our task today is to sharpen a cutting tool. We will need a blank solid tool like this one. We will need also a bench grinding wheel. We will need also a protractor, and we need also a coolant. So let's talk about different procedure or steps for grinding a tool. Step number 1, we will set the tool rest. This is the tool rest on our grinding wheel. This tool set will be set at an angle, a certain angle. Then we'll switch this one. I'll use this grinding wheel. Now, the second step is to move the tool side to side across the wheel. We need to make sure that our wheel is well dressed. If it is not well dressed, you can use this wheel dresser, but our wheels is well dressed. Let's start. We can check the cutting edge angle and the side clearance angle. If you look here, there is this side clearance angle. And even if you look here, there is an angle here. And if you look here, there is another angle here. Now let's grind the nozzle. If you look to our tool, there is an angle here. This angle is the side cutting angle. There is another angle here. This angle is the front cutting angle. Then there is a nozzle angle. This angle is the nozzle angle. Then, if we look on this side, the angle on the top is the back leg angle. On the top, there is an angle here. And on the front, there is an end clearance angle. With the skills of grinding or sharpening a cutting tool, you can sharpen different angle. For example, this one can be used for different operation like facing, straight turning. You can be also able to sharpen a tool like this one. This one can be used if you want to create grooves inside your workpiece. If you want to create grooves, this cutting tool can help you. And even if you want to do the parting off, if you want to cut the metal. You can also be able to grind a tool like this one. This one can help you to cut threads. And this shape must be the same with the shape of your threads. And you can also be able, by grinding this high-speed steel cutting tool, if you want to create to sharpen a tool to be used for internal threads, a tool like this one can help you to create internal threads. As you see, this tool can help you to create internal threads. Thank you for watching this second session of our lesson. See you next time. Our next session will be lathe machining work in a chuck.